Units also, not only from the numerical variables. In such case, you can't build a data cube, right? Data cube is possible only if you have some summary values on numerical things. But you don't have numerical things in certain cases. Then how do you go about it? That is based on the situation of the data and what you are requiring. So yesterday we have discussed the case in at level. But about the distinctive data mining also we discussed. That is what we did was we thought, okay, if we want to elevate the quality of the students in the university, what is it? The task relevant data is at your disposal. Then we decided that we have to segregate the students into groups and we have to study the group behavior. We have to study the behavior of two different groups. So what are the differences between these two groups, and to group B to attain the qualities of group A, what should be done? Like you can analyze at my class. That's what we did. So for that we decided that for the segregation of group or grouping, we have two categories. One is classification and one is cluster. And we have seen the details of clustering, how clustering will be done, how classification. Just broadly for the sake of understanding. Because clustering is entirely a total topic by itself. Okay. So we are studying first classification. So classification means you know the labels of the class. That is, you have some data, certain attributes will be there in the database table. Okay, and these attributes are related to some concept, and one label, special label called classes. Okay, so your classification problem typically is you have given set of data with attributes that influence the some process, and as per that a decision making is there in the class, the type of class. That means if attribute A is something, B is something, C is something, D is something, the class is something. Like you have the stuff there. And then classification means typically it is analyzing the existing data which has got certain values. You consider that data, you arrive at a model, right? You arrive at a model and you apply the model on some test data. The test data is also the data known to you, just for the sake of testing, right? And you will test whether all these rules derived by you using a model are accurate or not. You will decide a threshold percentage for the accuracy, because you will never get a 100% accurate model, because this is a statistical model. It is an approximation. Okay, this is not an exact one. In online transaction processing things, you need exact rows, exact fields and exact columns. But this is a predictive stuff at a higher level of granularity. This is related to statistics and decision. So here you will not have exact values, you will have approximation. So your model is accurate well within a threshold percentage. You get that kind of accuracy. Then you will say that the rules can be accurate. So that is classification part. And prediction part is, once this classified model, set of rules are arrived and tested, then you will apply these rules to the new data and decide based on that whether you to what class each row belongs to. You will predict the class. So that is classification and prediction. So without prediction, the classification makes no sense. Classification and prediction together makes sense. Is it okay for you? That's what we studied yesterday, right? Now we will take it far from. So now the questions we have to explore are, and I said in classification there are various methods, decision tree, nearest neighborhood, and various other classifiers are there, Bayesian classifier and all. Okay, out of which we are considering only the decision tree, which is a very old element, old model, old and standard model, a basic model for decision. So in this case, still you will be under dilemma. You are saying some rules can be derived. Again you are saying a tree. What is a tree? What is this rule? You are saying some test condition. How the test works? Test condition is framed. Which attribute I should consider? Right? How this tree will be helpful for me in classification? Right? Do you have all these questions now in your mind? So we will answer them one by one. So next slide please. Training and test sets we have got, and we have seen how the model is learning model, applied model. We have seen this. Next slide. Examples of some classification task is given. How you predict a tumor cell as beginning or management. Okay. Okay. How malignant cells can be their prediction. Classifying credit card transactions as legitimate or fraudulent. That's what we are going to just check. Classify secondary structures of protein as alpha helix and so on. And categorize news stories as finance, weather, entertainment, sport. Yes, these are few examples where we use classification. Next slide please. So what are different classification techniques? Decision tree based method, rule based method, memory based reasoning, neural network, navigation and based reasoning method, support vector machine. These are all different classification techniques. Nowadays support vector machine is a very popular model, that is a scalable model for very large data, because people use neural networks in our studies and all, but neural networks will have a limitation. That is, the neural networks methods are not scalable. So to make it scalable, the support vector machine concepts are coming. That requires a lot of mathematics. You have to have optimization within known first, and you have to use some of the vector calculus, and some of those concepts are required for support vector. This what is a very, very powerful model. Suppose somebody wants to really do good research in classification technique. Support vector machine is a very good model that is used for very high dimensional. Okay. So a lot of work is there. Somebody, one can do it, but you require sound math. You have to have the concept of optimization. And then apart from that, Lagrange multiplier should have analysis. So that Lagrange multiplier concept, and also smart multiplier. But the concept of support vector machine is, suppose in our linear space, okay, if you are not able to segregate, suppose you have three classes, plus, minus and into. Plus, minus, star. There are three classes of it. Suppose all plus are at one location, minus are, then you can classify. Because the thing there is, you want to draw a straight line, bifurcating the class. But your data is in such a fashion that, suppose one plus is here, again a minus, star, minus, like this. So a straight line cannot divide the stuff, because everywhere all the things are straight. Then what they do is they transform this plane into another plane using some kernel function model. Using that function, it will be transformed into another plane. That is, you know about logarithms. I just told you long back also. Transforming something into a different thing. Because in our normal linear plane, if a multiplication is there, when it goes to the logarithmic plane, it is converted as addition, right? Division is converted as subtraction. So you are finding out the logarithm of all values, then you are going to the logarithmic plane. There you are performing the calculations easily and transforming the value into the other thing. In a such a way, in support vector machine also, if you have the points, if you cannot separate them using some linear equation or something, you will have different kernel functions to find it. You will go to another plane wherein this can be transformed into linear segregation thing. There you classify the elements and then you come back to your plane saying that this is how you do. Some broader idea I am giving, not exactly. So you go altogether a different plane in doing this operation. That is your support vector machine. Just for your interest of understanding, I am telling you that so much work. When the dimensionality is very high. Normally, if dimensionality is more, your decision tree algorithm and all will. These things work for low dimensional data, because in the very beginning, the decision tree, other things, they were found because at that point of time, the business complexity was not more. People are comfortable with what you have, the preliminary model. But subsequently, when the concepts have changed, when the data has changed, when you have a kind of data with multiple dimensions, and you have a complex data, not simple data, you have a multimedia kind of data attached on the videos and everything. So in such case, these things will be very, very complicated. Now, if the data is too big, what to do? I told you it will be done in a distributed way. So for that, you have the Hadoop platform or even other big data platforms, wherein the big data version or the distributed version of these algorithms is also. There is one more direction for the data mining, because your data mining techniques will halt for some volume. Beyond that, they cannot work. Okay. So even a simple select statement of 2-3 fields from a table will fail if the data is of order of some trillions of data. A simple SQL cannot be run on that data. If you have around 500 crore or 1000 crore rows, single table with the name, roll number, maths, physics, chemistry, marks, simple table. And if you want to pick up the rows who secured more than 60% in some subject and aggregate greater than 60 and maths marks greater than 85, you want to pick up. It's a very simple query, right? Even that query, simple free, will not work if you have some 1000 crore rows. Okay. So there you have to immediately go for a distributed processing with big data. Okay. So that is altogether a different platform and different story. But why I am telling you is I am showing you the different ways, because at BTech level you are studying the preliminary thing. But I am showing you what is there in master thing. Just so that when you have studied these fundamentals, you will not stop here, but you will try to understand and assimilate what is there at multiple levels, how you will go about it. Idea. Okay. So here next thing. So example for a decision. Here see, refund marital status, taxable income. Okay. This is something like, here's an example of showing a decision tree, how it works. Let's take an example. I told you about categorical and continuous variables. All numerical variables are continuous and non-numerical things are continuous. And among these categorical variables and all, I said there is a classification, that is nominal, ordinal, interval and so here the class is, so somebody has a taxable income, somebody has a marital status, somebody has a refund status, that is whether his tax is a refundable tax or not. Then with these things they have an idea that somebody is a cheat or not a cheat. Okay. For that he has drawn a decision tree line. First he checked the variable refund SM, and of course you will get lot of questions. When there are three variables, why should you check refund? Why not marital status? Why not taxable income? Why only that? That's the question for you, right? Antena? Do you get that question at first? Why it is like that, I will answer. Okay? Now, at the first look, have an idea about how decision tree is. What is a root node, what are the intermediate nodes, and what is the leaf node? Just try to have an idea. Then from there, we will answer your questions one by one. Why the first one should be that, then why the second thing should be like that, and all we will discuss in detail. Okay. Now, see, the splitting attribute is refund, that is taken as the first. And for that, the answers will be yes or no, right? So, if your refund is S, you say that he is not a cheat. That means, normally when do you get a refund? When you file your income tax return, then the department will examine that. If you really get some refund out of your return file, then they will refund. So you have a refund in place, your case has been examined, and they felt that you deserve for a refund. So hence the refund is yes means no. No means cheating is no. Not that you are bad. Okay? So you are not a cheat. Okay. So if there is no refund, doesn't mean everybody is a cheat. If there is a refund, certainly you are not a cheat. You are never deceived. That's an acid test. So you need not be tested for that. Do you agree? So if it is not there, that means the splitting criteria, if it is no, then he had a condition against here. The marital status he has checked. Now obviously you will get why marital status, why not taxable income. That's the question. But you accept it as it is at this. The split condition as well as the remaining things you accept as it is, just to know how the decision tree is. Then I will explain you one by one how the things can be handled. So he has checked about the marital status, and you found that there are two conditions that are wrong. Because see, the marital, now let us examine the fields one by one. See, you have refund yes or no. Only this is a binary thing. Whereas your marital status is single, married and divorced. They are three cases. Okay. And taxable income is 125, 170, 120 lakh. This is the taxable income. And whether you are a cheat or not, you are not a cheat is mentioned here. If you examine here, majority are not cheats. There are 10 records taken for your training, out of which only 3 members are cheats. Who is a cheat? A divorcee who doesn't have a refund. With 95k income, he is a cheat. Again, a single with 85k income is a cheat. Again, a single with 90,000 income is a cheat. So there are 3 people who cheat here. Even refund is not there, all others are not cheat. See, a married fellow with 75k income is not a cheat. The refund status no is also not a cheat. And here also refund status no for a married fellow with 50k is not a cheat. No, it's a single status. Okay. Normally this looks like this. Suppose you have a car. You want to have a long distance drive. Then what kind of driver somebody? A driver who doesn't drink. Okay. Who is a safe person. An experienced driver. Then normally when some drivers are there, normally people check like this. What is his age? Is he married? The idea is that if a driver is married with some children and all, he knows the responsibility of the family and he will not drive rash. Of course, exceptions always will be. And normally if a person is unmarried, a careless man, aged around 20, 22, he will drive very rash. So, that means you will have an observation like this. Then if you want to hire a new driver, normally people say, okay, if he is a married person, he is known to some of your known circles elsewhere, then let us try. Accept. So what is this? This is also kind of classic. Okay? In children. So there is a general thing. Exceptions will be there also. Okay. Actually my driver is there. He got recently married. Before that, if I just leave him, he will go at 120 speed on the highway. I always control him. Then he will slow down. Again that works for a while. Again tends to drive fast. Again I will control him. Okay. So that is how it happens. Okay. Once or twice he tries to overtake an RTC bus. I just asked him, don't do that. Because if it happens, RTC bus driver doesn't lose anything. But you may lose your life or you may use your arms. If you lose your life, no problem. In 1 minute everything is done. But if you are hurt and if you have to depend on somebody for entire life, what happens? I just teach him right. Okay. Then he will be careful for some time. Now he got married. But still I warn him. Sometimes he tends to be late. Okay, so this was all out of experience we know. Okay, so in a similar way, out of this experience, he is arriving at the model. That is the basic stuff. Okay. Now, your marital status, single or divorced is one question. Married is another. Now also you will have a question. Okay, when 3 things are there, why not you split into 3 categories? That is one question you will have. Another question is, okay, you have split 2 things into one side and one point to the other side. Why single and divorced here? Why not single and married in the divorced other side? Why not single and married and divorced on other side? Why in this fashion only you have divided? Will be another question. Do you agree? Right? I will answer spot on. Okay. Accept. Because what are all possible questions that could arise, I am telling myself. And I am saying that I am going to answer. Okay. And then, after that, if the marital status is married, it is decided that you are not a cheat. Right? So, married person means he will never cheat. So, that means even though you don't have a refund status here, if you are married, you are not a cheat. Okay. And then, that's what I am going to tell you. That's what I am going to tell you. First of all, understand the branching. Then I will compare data and explain. Then I will explain each and every step how it is written. Okay? It is step by step process because it's a very new thing. You get 1001 questions. Okay? That's why I am telling, hold it for a while. I will answer every question of yours. I will not leave any question unanswered. Okay? Marital status is married means he is not a cheat. That is the meaning. Then, if the marital status is single or divorced, then check his income level. If it is less than 80K, he is not a cheat. So that means a single or divorced person still with lesser income in the lesser income group is not a cheat. Whereas if the taxable income is more than 80,000 and if he is single or divorced, he is a cheat. He is making all money. Okay? That is how the decision tree. That means the decision tree is like this. So now from this decision tree, how you make the rules, I am telling you. Only to that extent first you know. Then once I give the rules, then I will show you the data and compare the rules. Then after that in the other step, I will tell you why the rules are same, why the split criteria is there, how split criteria. You have the data, refund status of the tax and marital status as one field, taxable income as another field. Whether you are a cheat or not cheat is another thing. This is the class label, this cheat. Okay. So from this, we have derived a decision tree. Okay, a tree is like this. And from this tree, the rules are like this. Okay, I'll start. So, what rules are set from the decision tree? If there is a refund status is yes, so you check the refund status of the person. If he has a refund status, then he is not a cheat. If he doesn't have a refund status, then check the marital status of the candidate. And if he is a married, he is not a cheat. Okay? If he is not married, that means he is single or divorced. So the question there could be, is he married or not? Married doesn't mean either single or divorced. So that should be the question. Then check the taxable income is less than 80 or not. If it is yes, he is not a cheat. If it is greater than or equal to 40 less than you get 20, but somewhere equal to. So it is greater than or equal to 80. Yes, we do. So that is how your rules are. So there are 3 rules for saying somebody is not a cheat. There is 1 rule for saying somebody is. Okay? Please follow here. Because you are saying if tax refund is there, he is not a cheat. If tax refund is not there, but he is a married person, he is not a cheat. If tax refund is not there, and if he is a single or divorced, then if his income is less than 80,000, he is not a cheat. If his income is more than 80,000, he is a cheat. These are the rules you get. Now what happens is, suppose I give you a new set of data. There the class label will not be there. That will be closed. Okay? That will be closed. In such case, what you will do is, you will have only refund status, marital status and tax bill. Simply. Then a new record comes, let us suppose. The new record is, say, no, and he is divorced. His income is 55,000. The person is divorced, income is 55,000. He doesn't have tax rate. Then how do you classify? So how do you start with? I'll just try to note it and tell you. Because I want to make you people slowly digest the things. Now my question is, I have a person with no tax refund, divorced, with 55k annual income. Then to what category he belongs to? He is not a cheat. Another is tax refund is there. Okay? He is divorced. Income is 100k. Is he a cheat or not a cheat? How did you arrive? Does tax refund straight away though his income is 100k. Okay? Because what does one rule said? If a refund is not there, then only is said income is greater than 80k, the person is a cheat if he is a divorce. But here refund is there. So that means whenever a new tuple is given, then using this decision tree, so you will traverse as per the values, because you will see first of all what is there, refund status is there. So once the tuple is given, you will look at refund status what it is. Yes, refund status is yes or no. Then S is there, beside. If it is no, then okay, what is the next condition then? Marital status. Check that part. Then check the income. That is the order in which the things are given. Okay. You have to follow that order. Why that order I will explain. I told you. Need not necessary. In this case only, that's why in one of my questions I told you whether you have to ask multiple things or binary situation. Okay. Even that has lot of reason. Okay. So for all those things, one thing is the entropy calculation. Various things are there. You have a criteria of splitting a continuous material. You have criteria of splitting ordinal and different conditions of different. I'll explain one. Because again there are different decision tree algorithms. Certain decision tree algorithm you don't follow only binary. but certain algorithms follow multi-way tree. So actually you can decide depending on the information gain definition that is given, whether you can go for a multi-way tree turbine which is more useful, more advantageous. All those things are, they have a sound mathematical foundation. From there I'll answer everything. Because if I straight away say this is the split, now this is entropy, this condition, you end up lying in total confusion. So instead, because looking at my previous class experience about that, because you had a doubt about exactly, because your dimension one is also tabled other end. Nothing wrong, the doubt is very much justified. So at that point of time, I have to very clearly explain. So when I have explained with a practical example, you are able to digest, because these are all new concepts that require some slow digestion and that require your analysis with example. So that's why I have shown you this example and I asked you to slowly assimilate it. So that's why I have shown you how data will be. Then I have shown how decision tree will be. How you can arrive at the root from decision tree, how you can apply to new data, I told you so. Right? Okay. Now, you make the observation and this with the data. That is the next step I want you to walk. If you look at, this is the training data. From this data only, the tree is derived. So now let us cross-check whether this data and that tree are matched. Okay? I hope I am correct. Then you can understand slowly how the setup is. See, apart from this, I would like to generally advise you. If you are given a new problem and you are stuck at some point or a program is given, from the requirement document, you study the requirement document, try to simulate certain test cases and check the functionality. You try to solve it by it. Because when I studied tuning structuring algorithm, I am not able to understand. That is something referred to non-linear. So this was not taught to me because it was a new subject and I learned on my own analysis. Okay. So what I did was, okay, let me take some data sample data, some 10, 15 years and manually calculate. These things can go to 1 plus 1. The same mass is with different data values. And I applied chaining algorithm and manually calculate. Okay, what can be the case of one? Let me apply this and do the calculation, then observe it. How it is going. Suppose if I change this coefficient, any change in the element structure, iteration by iteration, how the values are changed. In Chinese question, if you change the centroid, again the values will change the value. So, how it is going on? I observed with some numerical value concerning certain action. Then I am able to understand. So that's the reason why you observe the data, it is going. It's simply not mugging up things. Yes, one more point before I forget, before I come to the actual training data, that is, you have that realize. Now, observe different things. What kind of notes are going to be? That's the first point. That's the point. If you observe, you have a root node. How is the root node? the root node has a label. In fact, that label is not really a label, it's a question. You said just the point we have mentioned. That means, do you have tax refund? That is the question. It's a question. Similarly, what is your marital status? Or are you married? A test condition. Again, what is your taxable income? Is it greater than 18 or not? So, like that, any node, either at the root level or intermediate level, has a test condition. So, the node will have a test condition. That is the first. So, if you look at your root node, how is it? Root node will not have any input, zero input, and one or more output. Root node will have zero input and one or more output. That is the criteria of your root node. And root node will have a test condition. You want to and then, if you consider the intermediate node, the intermediate nodes also will have test condition, definitely they will have a test condition. And but they have one input. They will have one input and one or more output. They will have one input, one or more output. That is how the intermediate. And if you look at the leaf node will have the class. So leaf node will have again only one input, no output. Root node will have no input, one or more output. Leaf node will have one input and no output. And leaf node will have the class label as the value, and all other non-leaf nodes, including the root node, will have test condition. The content of node will be the test condition. The content of leaf node will be the class node. Then what about branch? The outcome of your test condition, the output of your test condition, the result of your test condition is being depicted in the branch. Have understood that? Now I just told you how you read the decision tree. So we have seen a training data set from which a tree is derived and it is ready for operation. To that extent we are seeing. Once this tree is ready, now how different nodes are there in this tree, and then how do you frame the rules for classification from this decision tree we have seen. And another step is, last step we have seen, how do you, what is the last step we have seen? How do you classify a new record using this tree algorithm? Right? Is it clear? So I will give you just 3 minutes break. After the split, if all pluses go to one direction and all minuses go to another direction, then you say that it's a good testing. Now you have like plus and minus are there. 5 plus and 5 minus. Now we have a formula for disorder. That's called sigma I is equal to 1 to p of minus pi log P. That is the criteria for getting the information. Entropy. What is meant by entropy? Entropy is a measure for disorder in any system. Suppose in mechanical engineering also, people when they study about thermodynamics, they say entropy is more. That means when you heat the water, you will get steam. Even if the steam is at a very high temperature, then its entropy is more. Then it can run the engine in a much better way. Steam at very high temperature, its entropy is more. So as you increase the temperature, they say the entropy increases. Okay, that releases energy or something. Some kind of things you study. Okay, so in a similar way, here also, that means entropy is a measure for the disorder. Okay. So here, what is meant by disorder here? It's not any kind of agitation or dispute or something. Okay, you have multiple class elements are there in this singles. So there is a disorder here. Okay. So this a measure for this disorder is minus P log P. In fact, the derivation is not there in your textbook, but I have gone through the information theory. There is an electronics subject basically. In the information theory, there is a logical derivation to say why the entropy should be minus P log. I will just tell you the derivation in next classes. Subsequent classes, I will give that derivation to you so that you will enjoy it. Why it is. It is a simple logical theory. So, if you check here, in this case, you have two class levels, 5 plus 5. So, you have 5, how many, so what is the value of k here? No. N is number of records. I said k classes. 2. K is equal to 2. Very good. N is equal to 10. K is equal to 2. Okay. Now if you consider this as minus P log P. What is this P? The probability of ith class in this set, that is P. So, what is the probability of plus here? Exactly, 1 by 2. So, the probability of minus is also 1 by 2. So, if you consider minus of 0.5 into log 0.5 to the base, again minus of, so this is equal to minus of log 0.5 to the base. This will be the entropy. Why they put minus sign is, this will be a minus value. So minus and minus get cancelled. So you get a positive for the disorder. That's why minus sign is kept. Of course, I will give you the derivation. Right? So minus log of 0.5 to the base 2 will be, I don't remember, but it's a, it is minus 1, minus 3, plus 1. Okay. So it will be plus 1. So the disorder is highest. Okay. Now let us apply some test condition. Now you will have a doubt whether I should use A or B to say. Okay. Then if I use A as the one, what should be the Should I use A greater than 5, less than 5, less than 2? That is also another criteria. Or you have to use B. Now for this what you will do is, when do you say that the classification is good? After using some test condition, you will have two splits, let us say. Okay. If your condition could filter out and say that all pluses are here and all minuses are here, if your attribute test condition is like that, then you say that that is the best. Okay. So I'll show you an ideal case here. B greater than or equal to 10. Suppose, or else if I ask, is B less than 10? Yes and no. Okay. So your criteria is B less than 10. So B less than 10? Yes. Sorry. Yes, I can. Yes, I can. All plus. No, I can. All. So using this condition, you could comfortably filter. Now, why we have chosen that? For a while, let us keep that. Negatives. That's why I said this is no. This is yes. Okay. So now, because of this split, you have got all pluses here, all minuses. This is a good classification. Now, when you have this kind of good classification, what is the entropy here? Let us see. What is the probability of plus class here? 1. What is the probability of minus class here? In this split, 0. The probability of minus is 0. Probability of plus is 1. Now if you apply the condition for this portion, what is the disorder here?
Sir.
0, because minus log 1 is log 1 is 0
6 members
and 0 is 0. That part. Same case for the minus. So what is the total entropy of both the splits? 0 plus 0 is 0. So that means a maximum entropy of 1 is reduced to 0. When the entropy has become totally 0, you have getting my point?
Yes.
So now your criteria is you will check for the split and each and everything. How categorical things only we construct. Here only for your convenience I have shown numerical things, but they will be converted into categorical variables. Even the continuous variables also will be made into categorical variables when you are doing it. Then that is how the splitting will be taken. Now what we do is, we calculate the entropy on each attribute. So what you are supposed to do is, you calculate the entropy before split and you calculate the entropy after split of all partitions. Now, if there is a difference in entropy between these two, okay, if the difference in entropy is more, that means disorder has reduced. Suppose there it is there. Suppose after the split, 3 plus and 2 minus in one side, minus and 2 plus in another side. Again, the you calculate entropy, it will be something like 0.9 of both the things are 0.8. So 1 minus 0.8 is your gain, that is less. So that means if the difference is less, it's not a good split. If the difference is more, it is a good split. So for your sake I have shown an ideal case where it is done like that. But generally it will not happen like that. So what you will do is you will check with each and every attribute.
అంటే 8 కూడా కాదు.
Okay.
1 to 8.
And you calculate the entropy there. So with which value the entropy, rather the gain is more, rather the entropy difference is more. So that you will consider as the splitting attribute at the first. Then you will split it. Then you will recursively apply the condition at each and every node. And that is how you will construct. That's the basic. Of course, still more conditions will come into picture. How they will come, how it will resolve, we will see on the silver screen. At least your doubt is, the suspense is clear to some extent. How and how you can work out. Now you can take 2 examples. So in our next class, I will show you some examples, this algorithm, how different splits are there. It is a good split in different pieces, and all those things we will do, so that we will have an idea of this algorithm. And what is overfitting? That